Okay, so we're going to be proving parallelograms in a coordinate plane. So proofs in geometry is basically, you already know that it's a parallelogram. You're starting with that. And then you have to show me why you know it's a parallelogram. So we've learned the distance formula before. So let me just give you the formula for that. I'm not going to go through examples of the distance formula. We did that in prior objectives. So that is just the formula that you're going to need to use for some of these proofs. Parallel lines have the same slope. And you'll remember from algebra, the slope is m in an equation. The formula for slope is y2 minus y1 over x2 minus x1. So remember, parallel lines never intersect. And slope is rise over run. So that is the vertical distance and the horizontal distance, rise over run. So it is the same for lines that are parallel. Those are the little marks for parallel lines. Okay, so let's do an example. Bless you. Okay, we need to determine if lines A, B, and C, D are parallel, and it gives us the coordinates of points on those lines. So here's our formula. We're going to do this for line AB first. And let's label this x1, y1, x2, y2. So if you look up here, we need to do y2 minus y1 over x2 minus x1. So this is going to be, oops, this should be an x, sorry. This is going to be 6 minus 3 and 2 minus negative 2. Six minus 3 is 3, and 2 minus negative 2 is 4. So my slope for line AB is 3 over 4. So let's calculate the slope for CD. So for this one, I'm going to label x1, y1, x2, y2. 3 minus 0 over 3 minus -1. Which is 3 over 4. So the slopes are the same. So the answer to the question is yes, AB is parallel to CD. So that's how you use the slope formula to prove that lines are parallel. Now when I ask you to prove the parallelogram, I'm actually going to move this to the next page. I'm going to give you 3 methods to prove the parallelogram. Did everyone finish writing this part? Sorry, it's going up and down. Okay. I'm going to give you 3 methods for proving the parallelogram. In the practice, I want you to use all 3 methods. On the test, I will have you choose the method that you like the best. Method 1. Prove both pairs of opposite sides are congruent. So if we have our parallelogram, you're proving that AB is congruent to DC and AD is congruent to BC. You have to prove both things to prove that it is a parallelogram. If AB is congruent to CD and BC is congruent to AD, then ABCD is a parallelogram. For this method, you're going to use the distance formula. Method 2. Prove both pairs of opposite sides are parallel. So here's our same parallelogram. But in this method, I would be proving that AB is parallel to DC and AD is parallel to BC. If AB is parallel to DC and BC is parallel to AD, then ABCD is a parallelogram. For this method, you're going to use the slope formula. And the third method we're proving one pair of opposite sides are congruent and parallel. So this is the same parallelogram, ABCD. And we're just choosing one pair of sides. Let's use AB and DC, and we're saying that they are congruent and parallel. So in this case, we would be using the distance formula and the slope formula. Okay, let's do one example. I'm going to use method 3 since it involves both formulas. Again, you will have to use the distance. You're going to have to use all three methods on the practice. So if you're using method 1, you're using the distance formula 4 times because you need to prove the length of each side. If you use method 2, you're using the slope formula 4 times. If you use method 3, you're using the distance formula twice and the slope formula twice. Okay, so in this case, prove ABCD is a parallelogram. I always start with a sketch. Your sketch for every single problem can be the same. It doesn't really matter that it's plotted on a grid and that the coordinates are in the perfect place or that the shape even looks exactly how it's supposed to. What matters is the order of your letters. So if you're given parallelogram ABCD, your letters have to be in order. Okay, so it can be A, B, C, D, or it could be this way, A, B, C, D. It does not matter which way you put them. What you don't want is having A, B, and then C, D. Okay, they have to be in order around the corners. So however you write them, just sketch it out so that you know that AB and DC are opposite sides and AD and BC are opposite sides. Okay, so we're using method 3, so let's start with the distance formula. Let's prove the distance, or let's calculate the distance of AB first. Okay, so this is our x1, y1, x2, y2. -1 minus 4 squared plus 2 minus 3 squared. So you can put that whole thing in your calculator if you want to. This is going to end up being -5 squared plus -1 squared, which is 25 plus 1. So the distance of AB is the square root of 26. I'm just going to leave it like that. I don't have to convert it to a decimal. I'm just going to leave it as a square root for now. Okay, now I'm going to calculate the distance of the opposite side, which is CD. Because remember, you have to prove that opposite sides are congruent. So this is x1, y1, and x2, y2. Five minus 0 squared plus -2 plus 3, because we're subtracting a negative. So this is 5 squared plus 1 squared, which again is the square root of 26. So we have shown that those two sides are congruent. So I'm going to put my little marks here. We know that AB and CD are congruent. For method 3, I need to prove that that same pair of opposite sides have the same slope. So I'm going to use AB again, the slope of AB, and I use y2 minus y1 over x2 minus x1. 2 minus 3 over -1 minus 4, which is -1 over -5. So the slope is 1 over 5. So the slope of CD, -2 plus 3 over 5 minus 0, 1 over 5. So I have proven that the slopes are the same. So I'm going to put my little marks here that they are parallel. Same pair of opposite sides are parallel. So here is the final answer to my proof, and this is the most important part. You have to show your calculations, okay? You have to show that they match, but then your answer is ABCD is a parallelogram because, and then you're going to state what you just proved, which is that AB is congruent to CD and AB is parallel to CD. You have to show your work, but this is the answer to your proof. So that's what you're doing on today's practice.